All right, if you were with me on Friday when we looked at the line plot stuff, we focused on counting to figure out how many pieces a line plot is cut into. And we're going to do the same thing. We're going to figure out where certain points are, and then we're going to try to find the total and the range of a data set. If you were not with me on Friday, because there were a lot of you that were absent last week, when you figure out how many pieces a line plot is cut into, whatever the first whole number is, whether it's 0 or 10 or 105 or 7, you don't count the first whole number. So for right now, that 0 is just not there. You're going to start, counting at the first notch after the first whole number. So that 0 we're not using. We're going to start counting where the little a is. If I need to figure out how many pieces this line plot's cut into, I'm going to count all the way to the first whole number, and the first whole number is going to be 1. So if I'm not counting 0, this is 1, 2, 3, 4, and 5. That means that this line plot is cut into 5 pieces. But that also tells me that the denominator for all the fractions on this line plot is going to be 5. So if this is 0, this is just 1/5, 1 out of 5 pieces. 2/5, the second out of 5 pieces. 3/5, the third out of 5 pieces. 4/5, the fourth out of 5 pieces. 5/5 is the same as 1. If this is 1, then this right here would be 1 and 1/5. It's after 1, so you keep the whole number. And then it's the first out of 5 pieces. This is 1 and 2/5. This is 1 and 3/5. This is 1 and 4/5. This really would be 1 and 5/5, but 1 and 5/5 is the same as 2. Now, if you need to pause me, pause me. But for right now, I want your line plot labeled the same way as mine. Because if we can figure out how many pieces the line plot's cut into, and we can label the line plots correctly, then we don't have to take a long time to figure out where each thing is. Because you can see this would be A, this is B, this is C. This is asking me where point A is. But point A on the line plot is at 1/5. Point B on the line plot is at 1 and 3/5, and point C is at 1 and 4/5. Now, there are 4 different types of questions that they typically ask us about line plots. One of those would be the total and the range, but it only goes for the longest and the shortest piece. I'm going to put a little sentence here and here. Whatever I write down, I'm asking you also to write down. When you find the total of the longest and shortest piece, you are just going to simply add the longest and shortest piece together. Typically, these line plots, they say something about some girl. For some reason, they like to say some girl she has a ribbon collection. And she plots all the lengths of her ribbons on a line plot, okay? Because clearly she has nothing better to do with her time. If this is her line plot, the shortest piece would be the smallest number that actually has a data point there. And the longest piece is the biggest number that actually has a data point there. So if we were going to find the total of the longest and shortest piece, we would be adding the smallest number and the largest number together, okay? Range is a fancy word that means the difference. If they're asking us for the range of the data set, we are simply going to subtract the smallest number from the largest number. And it's not just the smallest number on the line plot. It's the smallest number that actually has data there. So subtract the smallest number from the largest number. Now, we have 1, 2, 3, 4 other line plots on this paper. what we're going to do is I'm going to go through and we're going to label these line plots. So we're going to practice figuring out how many pieces is this line plot cut into. We're going to figure out what is the shortest piece, what is the longest piece, what would the total and the range be. When you figure out how many pieces it's cut into, you do not count that first whole number. So again, this one starts at 0. This is starting at 2. This is at 0. This one starts at 8. It doesn't matter if it's 0 or 2 or 8 or 105 or 27. Whatever that first whole number is, because 0 is a whole number, we do not count that whole number. You start counting at the little, I call it a notch, but the little line after that first whole number. So if I'm trying to figure out how many pieces this line plot's cut into, that's 1, that's 2, that's 3, that's 4. You count all the way through to the next whole number, no matter what that number is. But because this stops at 4, that tells me that this line plot is cut into fourths. It's cut into 4 pieces. That means for every fraction on this line plot, your denominator will be 4. Now, because this is between 0 and 1, the whole number 0, this would just be 1/4 because it's 0 and 1/4. There is no whole number there. 0 is nothing. This is just 2/4. This is 3/4. This would really be 4/4, but that's 1. Now, because this is between actual whole numbers, it's after 1, so the whole number is 1, but we're back to the first notch, so that's 1 and 1/4. That's 1 and 2/4. That's 1 and 3/4. This is 2, which is the same as 1 and 4/4. Because this whole number is 2, that means everything after it is going to be 2 and something. But because this is the first one, this is 2 and 1/4. This would end here at 2 and 2/4. For right now, can you please make sure that you've labeled the line plot correctly? I'm asking, what is the shortest piece? It's not just this or 0. It's where there's actual data, either an X or a dot. But the smallest number that I have that has X's there is 2/4. That means my shortest piece is at 2/4. My longest piece would not necessarily be the last number. It's whatever actually has data there. And it doesn't matter that there's 2 X's here. There could be 7 X's here. That still is the shortest piece because it's the smallest number that has data. It doesn't matter if there's 1 X or 15 X's. It's just the largest number on my line plot that actually has data there. So for this particular line plot, my longest piece is 2. Okay? If I add these things together, that means I'm taking 2/4 and I'm adding 2 to it. So 2/4 and 2 is the same as 2 and 2/4. If that doesn't make any sense to you, then you put 2 over 1. Anytime you add or subtract fractions, you need a common denominator. And whatever you do to the bottom, I need you to do to the top. I know that 2/4 would stay because it already has a denominator of 4. 2 times 4 is 8. 1 times 4 is 4. 8 plus 2 is 10. And the common denominator stays. So as far as this line plot goes, my total is 10 over 4. Now, 10 over 4 is 10 divided by 4. And 4 can go into 8. 4 can go into 10 2 times. That gets me 8. 10 minus 8 means I have 2 left over, and my bottom number stays there. Okay? That's the total of the longest and the shortest piece. You take the smallest number that has data and the biggest number that has data, and you add those together. When you do the range, range is subtraction. So total's addition, range is subtraction. Sorry. I need you to put the bigger number in the front. That's my bigger number. My bigger number is 2. We're going to take 2/4 away. If you can figure out what that would be, cool. Okay? If you want to, I don't actually want to say that. If not, that's fine. Put 2 over 1. You know that anytime you add or subtract fractions, you need a common denominator. And between 1 and 4, my common denominator would just simply be 4. So 2 times 4 gets me 8. 1 times 4 is 4. I'm taking 2/4 away. Your common denominator stays, and 8 minus 2 is 6. That means for this line plot, my range, the distance or the difference between the shortest and longest piece, is 6/4. But that's also read as 6 divided by 4. And 4 can go into 6 one time. 6 minus 4 means I'd have 2 left over, and my bottom number stays the same. There's only 3 more on here, so I'm going to ask you just to go through and fill it out with me. We're going to keep doing the same thing. Guys, this new line plot here starts at 2. Whatever that first whole number is, we do not touch it. You don't use it. You don't start with 2. You start after that. So I'm not going to start counting with 2. I'm going to start counting here. So this is 1, that's 2, that's 3. You count all the way through to the next whole number, no matter what that whole number is. I can stop here because 3 is the next whole number I have. But that tells me that this line plot is cut into 3 pieces, which means that no matter what, the fractions on this line plot will all have a denominator of 3. Because this is not 0, this is 2. That means that every number after it is 2, and that would be 1/3. That's 2 and 2/3. This is 2 and 3/3, but that's the same thing as 3. Because this whole number is 3, everything after it has a whole number of 3. But you start counting over. So that's 3 and 1/3. That's 3 and 2/3. This would be 3 and 3/3. But we talked about this on Friday, how 3/3 is 1. So that's the same as 4. This whole number is 4, which means this would be 4 and 1/3. This would be 4 and 2/3 because you start counting over. This would be 4 and 3/3, but that's the same as 5. Because this whole number is 5, you start over. That's 5 and 1/3. Now, if I asked you for the shortest piece, it's the smallest number that actually has data there. If this is the line plot we're looking at, what's the smallest number that actually has data? It doesn't matter how many x's are there. It just the number matters. The smallest number that has any data here is this one. There could be 19 x's here. That doesn't matter. It's asking what's the smallest number that has data. That's my shortest piece or my smallest piece. That's at 2 and 1/3. Your longest piece, your largest piece, is the number, the biggest number that actually has data there. And the biggest number that actually has any data there is at 4 and 2/3. But that's why being able to label the line plot is so crucial and important, because if you can correctly label the line plot, then you just pull off the numbers you need. If we're going to find the total and the range, it's the total of the shortest and longest piece. So that means that I would take 2 and 1/3, because that's my shortest piece, and total means add. So I would add the longest or largest piece to it. Now the great thing here, this one we had to find a common denominator because one of them was the whole number. These already have common denominators. They're on the same line plot. All I'm going to do is do the backward C. That's 6 and 7. That would be 12. That would be 13 and 14. Common denominator stays, and 7 plus 14 is 21. That means the total of the longest and the shortest piece is 21/3. But that's the same thing as 21 divided by 3. And 21 divided by 3 is the same as 7. When you do the range, because range is a fancy word for the difference, which means subtraction, I need you to put the bigger number in the front. 4 and 2/3 was my bigger number. I've already done the backward C for 4 and 2/3 though, so I'm going to bring it down. We're taking the shortest piece away, and 2 and 1/3 was the shortest piece from this line plot. I've already done the backward C for 2 and 1/3, so I'm just going to bring it down. they should have common denominators. They're on the same line plot. And 14 minus 7 is 7. So that tells me that the range is 7/3. That is the same as 7 divided by 3. And 3 can go into 7 2 times. It gets me 6. 7 minus 6 is 1, so we have 1 left over. And your bottom number stays the same. If I'm going too fast for you, I'm sorry. You are more than welcome to pause me, rewind me. Okay, this is the only time you can pause me, so take advantage of it. Okay, because normally I just yip yap the whole time anyways. We will obviously keep practicing this. Even tomorrow, we're going to review this part before we look at any more types of questions. So at the very least, if all you can do today is just write down what you need, we will practice, and I will make sure that everybody is good to figure out how many pieces the line plot's cut into and figure out which one's the shortest piece and the longest piece before we go any farther tomorrow. So we have 2 line plots left on this paper. If you're overwhelmed, if you are confused, just continue, okay? Write down what I write down and make sure you put the paper in the green folder when you're finished because we're going to glue it in. And I promise you we will practice before we go any farther. Now, I'm going to go ahead and do the last 2 line plots. If the least you can do is just be with me and write down what I write down, that's fine. Please remember that when you figure out how many pieces your line plot's cut into, I don't care if it's a 0 or if it's the number 970. Whatever the first whole number is, you do not count that number. You start counting after that. For this line plot, it's only cut into 2 pieces. You count at the first notch after that first whole number, and you count all the way through to the next whole number. But my next whole number is right here, so I stop. This would just be 1 out of 2. That's 2 out of 2, which is the same as 1. Because this is after 1, the whole number is 1, and it's the first notch out of 2. This would be 1 and 2 over 2, 2 halves, but that's the same as 2. This is after 2, which means the whole number is 2. First out of 2 notches. 3 is the same as 2 and 2 halves. This is after 3, so 3 is the whole number. It's the first notch out of 2. 4 would be the same as 3 and 2 halves. This is after 4, so the whole number is 4, and it's the first notch out of 2. 5 would be the same as 4 and 2 halves. Now, I'm asking you for the shortest and the longest piece. The number of dots or the number of X's don't matter. The number matters. Your shortest piece should be the smallest number that actually has data there. My smallest number is just 1. Okay, it's the very first number that even has data. Your longest piece is the biggest number that has data there, that has an X there or has a dot there. So for me, in this line plot, my longest piece is 4.5. Total of the longest and shortest piece means you add those numbers together. Now, I can see that 4.5 plus 1 would be 5.5. But if that doesn't make sense to you, then you take it. If you know that 1 is the same as 2 over 2 or even 1 over 1, my goodness, let's just do that, okay? There's 1. 1's the whole number, you put 1 underneath it. If I want to add 4.5 to it, well, that's a mixed number, so I do the backwards C. That gets me 9 over 2. You know you need a common denominator, okay? So I can use 2, and whatever I do the bottom, I need to do the top. This will turn into 2 over 2. 9 plus 2 would give me 11, and your common denominator can stay. So the total between my longest and shortest piece is 11 over 2. That's the same as 11 divided by 2. And 2 can go into 11. What would it get me? 5 times. I don't know what I'm doing. Because 2 times 5 is 10. 11 minus 10 means I have 1 left over. And my bottom number stays the same. The range is a fancy word for subtraction. It's finding the difference. As long as you can remember to put the bigger number in the front, okay? If you can see that that should clearly be 3.5, cool. If you can't, then you just do it the long way. That's going to get me 9/2. I would need a common denominator. So now I'm subtracting. That would get me 7/2. And that's really 7 divided by 2. And 2 can go into 7 3 times because it gets me to 6. 7 minus 6 is 1. And my bottom number stays. There's only one more, and I feel like a lot of you probably, like always, are thinking I'm talking way too much. So I'm going to walk us through one more. Just write down what you need, and then we'll be done. You do not start counting with 8, you start after. So if I'm going to figure out how many pieces this line plot's cut into, that's 1, that's 2, that's 3, and 4. You count through to the next whole number. Because this is 8, this is also 8. That is 8 1/4. That is 8 2/4. That is 8 3/4. This would be 8 4/4, which is the same as 9. If this is 9, you start over. That's 9 1/4. That's 9 2/4. That's 9 3/4. 10 would be the same as 9 4/4. If you get to the next whole number, here is 10, then you start over. That's 10 1/4. That's 10 2/4. The longest and shortest piece, the X's or the number of dots don't matter, the number matters. The shortest piece is the smallest number that actually has data. So for this line plot, this would be my shortest piece. It's the first number I come to that actually has some data there. My longest piece is the last number or the biggest number on my line plot that actually has data there. So I'm going to write down that my shortest piece is 8 3/4. I'm going to write down that my longest piece is 10 1/4. I'm going to let that focus. Okay. Total of the longest and shortest piece, you add those numbers together. They're already on the same line plot, so they already have a common denominator. If you can see what this would be, great. If not, I'm going to take 8 3/4 and I'm going to add 10 1/4 to it. These are mixed numbers. So that's 32, that's 33, 34, and 35/4. That's 40 plus 1, so 41. Your bottom number, your common denominator, is going to stay. I know that 5 and 1 is 6, and 3 and 4 is 7, so that gets me 76/4. That's 76 divided by 4. Okay? If you don't, well, actually, I don't want to say that. I'm just going to do it off to the side just in case. I don't want to confuse anybody anymore, okay? 4 can go into 7 one time. 7 minus 4 is 3. That gets me to 36. And 9 times 4 is 36. So that tells me that 76 divided by 4 is the same as 19. Now, just so I can show this to you, okay, this is what I was doing. This is why I'm saying if you can see it, great. If you can see that 3/4 and 1/4 would get you 4/4, that's a whole. I know that 10 plus 8 is 18, so that gets me 18 4/4. But if you know that 4/4 is a whole, 18 plus 1 more, it already is 19. Okay? I'll show that to you again tomorrow. So if you're like, what the heck? Don't worry about it. I'll show it to you. The range, fancy word for subtraction. You're going to put the bigger number in the front, and you're going to subtract the other number. Okay? My longest piece minus my shortest piece. I've already done the backwards C. That gets me 41/4. That is 32, 33, 34, and 35/4. Your common denominator, because you already have one, they're on the same line plot, and it stays. If I'm at 35 and I count up to 41, I've got 36, 37, 38, 39, 40, 41. That's 6 fingers. So I'm at 6/4. That is the same as 6 divided by 4. 4 can go into 6 one time. Gets me to 4. 6 minus 4 is 2. There I go. Guys, I know, first off, it says it's been 25 minutes, so I'm very sorry. You guys know I'm long-winded. If the very least you can do is just write down everything I have answer-wise. We are going to glue this in tomorrow, and if you still are confused, I promise you we will go over this before we do anything else. For right now, I want you to put this in your green homework folder. There is a few exit ticket questions that go along with this. It's not a grade. Exit tickets are never a grade. It's the very next thing for you to finish on Schoology. I just want you to try it, okay? You're going to have to figure out how many pieces that line plot's cut into. You're going to have to figure out where certain things are. And just see, can you try to answer the questions, okay? It's not a grade. So just do your best and submit it. I don't care what the score is. It's just going to show me, do we need to spend a lot of time looking at this tomorrow, or are we good enough where we can just quickly review it and move on?